Welcome to section 12.3 in chemistry. I know it's a little backwards. We skipped 12.2. We're going to go over 12.2 in class tomorrow. What we're going to do is 12.3 today, and 12.3 is kind of math-based, and we're going to focus on concentration. Now, what is concentration? It's how much solute you have dissolved in your solvent. So think of you're making Kool-Aid, for example. Now with Kool-Aid, I know all of you guys like to have 90,000 cups of sugar in it. So think about if you make Kool-Aid where you add 1 cup of sugar to it. The directions say you're supposed to add half a cup, right? That's pretty concentrated. But all right, let's say we really want to up the sugar dosage in our Kool-Aid and we add 5 cups. Which of those two has a higher concentration? The one with the gallon of Kool-Aid with 5 cups or the gallon of Kool-Aid with 1 cup? Right? Quite obviously, it's the gallon of Kool-Aid with it is the gallon of Kool-Aid with 5 cups that has the higher concentration. And that's what we're going to do today is we're going to start figuring out the concentrations of solutions. We've talked about concentrations before in regards to acids. You guys have worked with what I call low concentration acids and high concentration acids. And remember, anytime we've talked about high concentration acids, there are more safety risks involved when we work with high concentration acids in the lab. So when we talk about concentration, we're going to be able to calculate concentration in 2 ways, molarity and molality. And there's a small difference between the two. And what we're going to do is we're going to focus on molarity because molarity is about 90% of the time what we calculate our concentration with in chemistry is molarity. So molarity is a capital M. Molarity is a capital M, and the equation for molarity is right here. Capital M is really equal to moles divided by liters. Now, if I put that in a division circle, molarity is equal to moles divided by liters. So if you ever need to solve for something, you cover up the M for molarity, it's equal to moles divided by liters. You cover up the L, and liters is equal to moles divided by molarity. And if you need to solve for moles, you're going to multiply capital M and capital L, molarity times liters. So what we're going to do is we're really just going to go through and do 2 math examples, one with molarity, one with molality. Now I know it's possible that when you're looking at the actual notes online, not the video, the notes online, that the problems and the work is already done for you. That's fine. I'm just going to kind of walk you through this. So first question. You have 3.5 liters of a solution that contains 90 grams of sodium chloride, NaCl. What is the molarity of the solution? So we are asking for, what is the molarity? So we are asking for capital M. Remember that molarity is equal to moles divided by liters. Do we have moles? Does it come out and directly tell us the moles that are in this problem? It doesn't, but what does it tell us? It tells us that we have 90 grams of NaCl. Well, we can convert grams to moles. You've been doing it all along. This is really just a one-step railroad track. We're going from grams of A to moles of A. So to get moles, what we're going to do is we're going to start with our 90 grams. It's our 90 grams of NaCl. All right, railroad track. I want to go to moles, so I'm going to put moles on the top. I'm going to put grams on the bottom, grams of NaCl. When you go grams to moles, what always goes in front of the moles? A 1. What number is going to go here? The weight of NaCl. So on your periodic table, you're going to look at the weight of Na, which is 22.99. You're going to find the weight of Cl, which is 35.45. And you're going to figure out that the weight of NaCl is 58.44. So right here, I'm going to plug in 58.44. And when I figure that out, I end up figuring out that I have 1.54 moles of sodium chloride. All right? Good. So that's part of my problem. So molarity, it's asking for what is the molarity of the solution. Molarity is equal to capital M. Molarity is equal to moles divided by liters. Well, our moles is 1.54 divided by how many liters of solution do we have? 3.5. So we're going to plug in 3.50 there. So we're going to go 1.54 divided by 3.50, and that is going to give us an answer of 0.44. Now, when we write the unit for this, we're just going to use the abbreviation. How do we abbreviate molarity? With a capital M. So it's going to be capital M. But capital M, what chemical or compound are we dealing with? We're dealing with NaCl. So our final answer will read 0.44 molarity NaCl. Now remember, I did not do the division circle here, but just a friendly reminder for the division circle, molarity is equal to moles divided by liters. So if you need to rearrange that, there's a kind of a quick way to help you rearrange that. So that is molarity. Molarity uses moles divided by liters. Next up, we have molality. So we have molarity, which is a capital M, and we have molality, which is a lowercase m. As I mentioned, for the most part, chemists use molarity. Occasionally they will use molality. And what is the difference between molarity and molality? Well, as we talked about, molarity was abbreviated with a capital M, molality with a lowercase m. Let's go ahead and look at the equation here. Molality, little m, is equal to moles divided by, here comes the difference. Molarity was liters. What is molality? Molality is kilograms of our solvent. And remember, our solvent is what does the dissolving. So if we are going to make a circle for this, it's going to be little m, molality, is equal to moles divided by kilograms of solvent. And that's the key too, is don't forget that kilograms of solvent. That's going to kind of come back and be a stickler in some of these problems. So molality equal to moles divided by kilograms. Let's go ahead and let's do an example here. A solution was prepared by dissolving 17.1 grams of sucrose in 125 grams of water. Find the molal concentration. Now, molal concentration is the same as molality. If I asked what is the molar concentration, you would solve for molarity. So molal means molality, molar means molarity. So find the molal concentration. All right, now one thing that's different here is you're given 2 grams. You have to figure out what the grams are. And you really have to think about what's being dissolved and what's doing the dissolving. So what is our solute and what is our solvent? A solution was prepared by dissolving 17.1 grams of sucrose. This 17.1 is what's being dissolved. The 125 grams is what's doing the dissolving. So we said it's asking for find the molal concentration. Well, that is molality. So we know molality is equal to moles divided by kilograms of our solvent. So we are going to be stuck with finding molality, which we don't know. Next up, moles. All right, can we figure out moles? Yes. We're going to have to do the same process we did when we solved for molarity to convert to moles. They give us 17.1 grams of sucrose. So again, we're going to have to do a one-step railroad track going grams of A to moles of A. 17.1 grams of sucrose. I'm just going to abbreviate here. It should be SUC. We'll just do the whole thing here. 17.1 grams of sucrose. Remember, on the bottom, what do we want? We want to cancel out, so we're going to go grams of sucrose. And we're going to go moles of sucrose. And remember, anytime you go moles to grams or grams to moles, a 1 goes in front of the moles. Now, you could figure out the weight of sucrose, which is this, but I was nice enough to tell you the molar mass of sucrose is 342.3. So we're going to plug in 342.3 grams right in there. 17.1 times 1 is 17.1. 17.1 divided by 342.3 gives us 0.05 moles of sucrose. So we have one of our two things in the equation. Molality is equal to moles divided by kilograms of solvent, or molality is 0.05. Next up, divided by kilograms of solvent. Well, our solvent is water. Water pretty much dissolves lots of things. It's not quite the universal solvent, but it's darn close. In 125 grams of water. Well, grams is not kilograms. So the question becomes, how do we get grams into kilograms? Remember, you're going to divide by 1,000 or move the decimal 1, 2, 3 to the left. So when you move the decimal 3 to the left, now you're in kilograms, and you're going to have 0.125 kilograms. What we're left to do is divide 0.05 divided by 0.125, and we're going to get 0.40. Now the big question is here, what's our unit? We're solving for molal concentration, or molality, so little m, and it is sucrose is what we're solving for. So 0.4 molality sucrose. So when we deal with concentration, concentration is an idea of how much we have in solution. We use two things, molarity and molality. Molarity, moles divided by liters. Molality, moles divided by kilograms of solvent. You'll be getting a worksheet on this. The worksheet's due tomorrow. If you have questions, we'll talk about this in class tomorrow. Have a great day.